Lesson 52 is going to cover multiplying rational expressions. Very similar to multiplying fractions. Okay, when you multiply rational expressions, in order to do that, you multiply your numerators and multiply your denominators as you would a fraction. Basically, if you look at this, when you multiply the polynomials or multiply these together, you have a times c giving you ac. That's multiplying your numerators. You have b times d giving you bd. That's when you multiply your fractions. Now, if you look at the example below, okay, this is your rational expressions here. Basically, you have x times 3x to the third. So we get 3x to the fourth, because when you multiply, they have the same base. You add the exponents. Here, you have your denominator. You have 2x minus 3 times 5. So we just write it as simply 5 times 2x minus 3, because that 5 needs to get distributed to everything, to that binomial, 2x minus 3. So the first example that you have is a lot of people want to go ahead and take 3 times 4 right away, get 12. I wouldn't recommend doing that. Reason being is normally when you multiply fractions together, and I'm just going to start something generic here. Say you had 4/9 times 5/16. Normally when you multiply fractions, you don't go ahead and just take 4 times 5 and get 20 and then 9 times 16 to get your answer. Normally what we would look to do is to reduce within your problem. So I look here, if I can take a 4 out of this, it's going to be a 1. Whatever I do to a numerator, I have to do to a denominator. Now I can't take 4 out of the 9, but I can take it out of the 16. 4 goes into 16 4 times. So then when I multiply here, I can't reduce anywhere else. I would get 5 over 36, and that would be reduced. So that's what you want to kind of do as well, is try to reduce within your problem right away. So the first example, I look at it, and I can reduce in this. I look diagonal here, and actually 4 and 10, I can reduce 4 and 10 right away, or I can just go ahead and take the 4's out. It doesn't matter. So let's say I decide to go take a 4 out of that. If I take it out of the numerator, I need to take a 4 out of the denominator. 4 can't be taken out of 10. 2 can. However, I look diagonal, and I can take a 4 out of that as well. So now when I multiply, I have 3 times 1 is 3 over, basically this would be 1 times 10 to the x to the third power. So 1 times 10 to the x to the third power would give me 10x cubed. Example 2. Same scenario here. Look to see where you can reduce within the problem. So I look, and I can actually take a 5n squared out of the top. If I take it out of the top, I have to take it out of the bottom. I also can take a 3n plus 7 out of the top. What I take out of the top, I need to take out of the bottom, 3n plus 7. So basically, this would give me 1 here. I would have 1 times 5n squared, which would give me 5n squared, all over 3 times, well, this is 1 over here. 3 times 1 is 3. So my answer is 5n squared over 3. Next example, look at it, and again I can reduce within this problem. I can take a x minus 5. This is a binomial here, and if I can take the binomial off the top, so I have to be able to take the binomial off the bottom, which would both give me 1. Now when I write this problem out, right now I have 1 times x squared plus x minus 12, and this would all be over that binomial x minus 3. The next thing that you're going to want to check for is reducing that binomial or trinomial down into 2 binomials if possible. So I see that that trinomial is plus minus. I'm going to see if I can't reduce it down here. Plus minus will give me plus minus, and I have x times x. Then the next term I need to think, well, what has a product of c that has the sum of b? So that would be 4 times 3 would give me 12, and I need to have a sum of b, so 4 would be the positive, 3 would be the negative, and this is all over, again, x minus 3. So now, really, I can reduce again. I can take a binomial out of each, the top and the bottom, x minus 3, x minus 3. So your answer here in example 3 would be x plus 4. That is the only thing that is left there. Example 4, in this problem I'm going to want to do a lot of simplifying down here. So I'm going to say here's this first part here, that first rational expression. I'm going to say k plus 8 over. I'm going to see if I can't break down k squared plus k minus 2 into two binomials, in which I can. So I have k, I see plus minus up there, so I'll have plus minus down here. So I should come up with k plus 2 and k minus 1, and this would be multiplied by, look at this 6k minus 6. I can factor out a 6. When I factor out a 6, I'm left with k minus 1. And again, a way to double check is go ahead and distribute that 6 back in there, and you would find out that you would wind back up with 6k minus 6. So I factored out a 6, and on the bottom I have 6k plus 30. Again, I should be able to factor out a 6, and when I factor out a 6, I have k plus 5. Now that I've factored everything down and simplified everything, what I need to do is simplify this process even more and determine what I can take off the top and the bottom here before I multiply. Well, I can take a 6 off the top and a 6 off the bottom. I can take a k minus 1 off the top and a k minus 1 off the bottom. So basically what I would wind up with is, in my numerator, k plus 8, and this really over here would be times 1. So I have k plus 8 over, on the bottom, what I'd be left with is k plus 2 times k plus 5. You can multiply it out, but however, it's not necessary. So this here in example 4 would be our answer. This will conclude lesson 52, multiplying rational expressions.